Mega tunnel drilling machines, often referred to as tunnel boring machines, TBMs, stand as marvels of engineering architecture. These colossal machines serve a vital role in modern infrastructure, excavating tunnels with precision and efficiency. Unlike traditional drilling methods that can be hindered by time or potential hazards, TBMs can smoothly navigate through diverse geological terrains, making them indispensable in large-scale projects for transport, allowing these machines to maintain their trajectory and depth to a remarkable degree. Coupled with automation and artificial intelligence, TBMs can analyze real-time data to optimize operational speeds and predict soil conditions. For those challenging terrains where groundwater poses a risk, pressurized face systems maintain a stable environment, preventing flooding and keeping geological integrity intact. These innovations represent not merely a leap in machinery, but a transformative evolution in how we conceive underground tunneling. Imagine the immense magnitude of a tunnel boring machine, TBM, a veritable titan of engineering, powering through the subterranean world. At its front lies a rotating circular cutterhead, formidable and sharp, bristling with multiple disc cutters and scrapers designed for the most challenging geological formations. This machine, encased within a robust cylindrical steel shield, advances with relentless determination through rocky corridors, carving out a path where none existed before. As the TBM progresses, hydraulic jacks come into play, providing the necessary force to push the giant forward with precision. Each thrust feels like the heartbeat of the machine, synchronized with the rhythmic churning of its cutterhead. With every rotation, earth and rock crumble away, yielding to this technological marvel. Meanwhile, conveyor belts hum steadily, crafting a continuous flow as they transport the excavated material away from the crowded tunnel, creating an efficient system that keeps the operation moving smoothly. Behind the steadfast TBM, workers tirelessly install precast concrete segments that elegantly reinforce the newly forged tunnel walls. Each segment slots into place like pieces of a vast underground puzzle, creating a secure pathway that will withstand the test of time. Bright lights pierce the darkness of the subterranean environment, illuminating both the machine's metallic components and the dedicated personnel ensuring its success. A control station, replete with screens and gauges, serves as the nerve center where operators carefully monitor the TBM's progress, analyzing data around domain of engineering prowess. The TBM stands as a testament to human ingenuity, burrowing ahead, creating tunnels that connect our world in ways both visible and unseen.
Complex system composed of several key components, including Cutterhead. The front of the TBM is equipped with a rotating cutterhead that is designed to grind, cut, or crush the soil, rock, or other material in its path. The cutterhead typically has various cutting tools like disc cutters, for rock, or scrapers, for softer soil. Shield, a cylindrical steel shell that surrounds the cutterhead and the working area, protecting workers and machinery from cave-ins and supporting the surrounding ground during tunneling. Thrust system. Large hydraulic jacks push the TBM forward against the tunnel face as it bores through the earth. The TBM continuously moves forward as material is removed. Conveyor belt or screw conveyor. Excavated material is transported out of the tunnel through conveyor systems to keep the tunnel clear and safe. Grouting system. As the TBM moves forward, the machine also applies grout or concrete to the tunnel lining, reinforcing the structure and ensuring that it can bear the weight of the surrounding ground. Segment erector. In some TBMs, precast concrete segments are installed behind the cutterhead to line the tunnel. This keeps the tunnel stable and reduces the risk of collapse. Power supply and control systems. TBMs are powered by electricity or hydraulic systems, which drive the cutterhead, conveyor belts, and other functions. The machine is controlled remotely by operators who monitor its progress and adjust the systems accordingly. Technology of mega tunnel drilling machines. Modern TBMs rely on a variety of advanced technologies to improve efficiency, safety, and precision. Some of these technologies include laser-guided navigation. TBMs are equipped with laser guidance systems to ensure precise tunneling, maintaining the desired direction, depth, and curvature of the tunnel. Automation and AI. Many TBMs incorporate automated systems and artificial intelligence to optimize cutting speeds, predict soil conditions, and manage risks such as ground subsidence. Pressurized face system. Some TBMs are designed to operate under high pressure, particularly when tunneling through soft or waterlogged soil. This prevents water from flooding the tunnel and keeps the ground stable. Condition monitoring systems. Sensors throughout the TBM constantly monitor the condition of the machine and the tunnel, alerting operators to potential maintenance needs or emerging problems. Earth Pressure Balance (EPB) machines. EPB TBMs use the excavated material to create pressure against the tunnel face, balancing the pressure in unstable ground to prevent collapse. How TBMs work. The TBM operation involves several stages, usually executed in a continuous cycle.